So water, instead of getting contracting, it expand below 4 to 0 degrees Celsius. This is called anomalous expansion of water. So density is maximum at 4 degrees Celsius. Okay, let's move to the Pascal's law. What is Pascal law? It says that if there is a enclosed fluid, okay, that is a fluid in a container, okay, and it has to be incompressible, then if we apply pressure to any part of the fluid, then it will be distributed, transmitted to the whole fluid undiminished way. Okay, suppose I exert a force pressure of 10 newton here. Okay, so at any other point I will get exactly 10 not newton, that is Pascal. Okay, the unit is Pascal, then exactly 10 Pascal I will get at every point on the fluid. This is the Pascal's law. Okay, now next topic is variation of pressure with depth. So what it says that how the pressure changes when we go within the depth. Suppose inside the ocean, we go inside the ocean. Okay, we are at a height, depth h inside the ocean. Okay, how much will be the pressure at this point? So, and the density of the water, suppose that is rho, so the pressure will be h rho g. Okay, and obviously this pressure will be, suppose the derivation is given here. Okay, so suppose we have a what, suppose there is a at this point the mass of the yes, air column or the water column at this point is, no, this is m mass. Okay, m mass, and the what will be the reason of the weight here? The weight will be because of this mass and multiply by g. Okay, and this is the force acting on this area. Okay, and if we divide this by the area, we got the pressure, and we can write mass as density into volume. Okay, and volume again we can, for this cubical or cuboidal shape of the water column, we can write rho is equal to a into this height, this height h rho, then g, so we can get the pressure as h rho g. Okay, again one more thing is like this is, okay, suppose the at this point the pressure was because of the air column or the water column, and also due to the atmospheric pressure. So let's understand this. Okay, the total pressure acting on the body or that point at h depth was equal to, suppose there was 100. Okay, there is a body here at h depth and it was experiencing 100 pressure. I'll take the pressure due to atmosphere also is there. Okay, so the pressure due to atmosphere was suppose 30. So 100 minus 30, this was the total pressure acting on the body. This is for the atmospheric pressure. 100 minus 30, it is the pressure due to this air column, water column. That is what we call gauge pressure. So gauge pressure is basically total pressure minus the atmospheric pressure. We will exclude the atmospheric pressure in that, and what we obtain is a gauge pressure. The formula would be, this will be the formula. This is the total pressure, atmospheric pressure plus rho hgh, and this will be equal to P minus PA. This will be the gauge pressure. Okay, then we have atmospheric gauge pressure. I have talked about that. There is a device called manometer that is used to measure the pressure. Okay, we have pressure device, manometer. Okay, tortoiseshell is also your unit of pressure. Okay, 133 Pascal. We should know the different unit of pressure. One unit is 70 centimeter in of hg we measure pressure. Okay, so manometer, basically barometer works like this. Okay, barometer is device to measure pressure. What we take a, a, a trough. Okay, and it is of mercury, basically a container of mercury, and in that what we do, we take a test tube filled with mercury, and in this trough there is a mercury filled. Then we invert it on the this trough. Okay, so we see that some of the mercury gets down, but at a certain point stops a certain level, and we measure this height, and that will equal to 76 centimeter. Rather to say, yeah, this is 76 centimeter, yes, or 7760 millimeter. So because this mercury height, this is exerting some pressure at this point. Okay, this height, how much it is exerting? H rho g, this height multiplied by density of mercury, and the H rho g that we have understood the formula. And at this point the atmospheric pressure is exerting pressure. Okay, and we know at a certain, there's one more point that you should remember, at a particular level, horizontal level, the pressure of each point at a particular level is same. So this should be equal to the atmospheric pressure. So this is how we measure atmospheric pressure, okay, by the use of barometer. Okay, so one unit is 76 centimeter in the terms of Hg or mercury we can measure. Okay, other units of pressure are 1.01 into 10 to the power 5 Pascal. This is the atmosphere, this is the atmospheric pressure. Okay, and this is also one atmosphere. Okay, so you should be familiar with different unit. Torricelli is 133 Pascal. Okay, then we have, this is what I was talking about, and then we have the application of Pascal's law. So hydraulic machine is hydraulic lift is there. Basically what what we have seen that in a, I told you that Pascal's law, pressure, what pressure we exert at a point, it will be equally and undiminished, in a equally and undiminished way will be transmitted to the other point. So the pressure here and the pressure here will be equal. And what is pressure? We know pressure is force upon A. The pressure at A and B point will be equal, and pressure is force at A and upon area at A is equal to press force at B upon area at B. Okay, so you see the force, the area here is more, area in this case is more, and the area in this case is less. So you can do the calculation here. Suppose this is, I'll take an example. This is a force I have applied, 10 force I have applied, or 100 force I have applied. Area here is 10. It should be equal to, the ratio should be equal, the area there was 20. So how much be the force here to make this ratio equal or proportion equal? It must be 200. So you see, the greater area there will be more force due to Pascal law. So with a little force we can we can lift even a car. Okay, so this is hydraulic lift. Hydraulic press work on the similar principle, and there are hydraulic brakes too. Okay, now very important topic, streamlined flow. So what is a streamlined flow? So basically, okay, you see that there is a flow that is very smooth. You see on a river or in a pipe, there is a very smoothly the, that is called a streamlined flow, laminar flow. But the correct definition of that is a, you see, there is a, okay, there are this is a tube or a pipe, and there is water flowing through it, and there are different layers of the water in this. Okay, let's take a point, a particular point P. Okay, so the water molecules of water are passing. Okay, they will reach this point one after the other. Okay, so at a particular instant the velocity at P point of a particular particle was 20. Okay, now the first particle goes away, the second particle comes at this particular point again, the velocity I see is again 20. Then third particle come, third molecule come, and this particular point again the velocity is 20. So this is called streamline flow. So streamline flow is one in which at a particular point uh, the velocity of each and every molecule passing through that point will be equal. That will be termed as streamlined flow. And again we can come up what is turbulent flow. The velocity at of each point, of any point for different molecule will be different, that will be termed as turbulent flow. The streamline flow is called, also called the laminar flow, and each part taken by fluid will be called a streamline. Okay, then we have equation of continuity. Okay, so this, you see there is a pipe like this. Suppose the shape of the pipe is something like this. You see the area is here is less, the area here is more. Okay, so the mass entering this pipe, okay, it not, suppose 100 mass enter the pipe, how much mass will be taken out? Okay, obviously it will be at a particular instant it will be 100. Okay, so we see the mass remain the same, it cannot be miraculously increase or decrease, the mass will be same. So because we, through this we can arrive at a formula, that is a1 v1 is equal to a2 v2. That is the, this is called principle of continuity. A1 is the area of the first region of the pipe, first area of cross section, and v1 is the velocity at that particular area of cross section. A2 is the area at another region and the velocity there. Okay, and we have derived this from the mass only. Okay, and this is a principle of continuity. Then we have Bernoulli's, very important Bernoulli's principle. So what Bernoulli principle is? It is based on the law of conservation of energy. Okay, so see, for this we have certain conditions or certain assumption that we have to make. The fluid has to be ideal. By ideal I mean it should be incompressible. It will be applied only to the streamlined flow, not to turbulent flow. And then we have, okay, so just understand the energy, total energy here. The energy will be pressure energy, the energy will be kinetic energy per 1 unit volume, and then energy will be uh, potential energy. Sum of all the energies here at any point and here will be equal. This is Bernoulli's principle. Okay, so what is the statement? Okay, this will be equal to the pressure per unit volume plus kinetic energy per unit volume plus potential energy per unit volume will always be constant. Okay, so pressure energy is basically, okay, for uh, moving this fluid upward we have to apply certain pressure, certain force, that will be the pressure energy per unit volume. Okay, we'll take the per unit volume. Okay, and then there will be, at we are considering at any point, so suppose this point, okay, we had applied a pressure here, and at this point, just a second, yes, okay, so what happens now? So at this point the pressure energy plus there will be pressure, okay, and it will be converted, that pressure energy that we have given, it will be converted to kinetic energy. Okay, because of the movement of the particles of the fluid, it will be converted to potential energy because it has reached some height. Okay, and then at we take another point. Okay, now the fluid will be exerting some pressure. Okay, their work was done on the fluid, now fluid is doing some work, okay, on the neighboring particles, neighboring fluid. Okay, there will be pressure energy. Okay, and there will be change in the kinetic energy, there will be different potential energy. Okay, and they'll, but their sum will be the both, that is 10, potential energy is 10, put only 20, and pressure energy is 30, the sum will be equal. Okay, so this is but not very important. Okay, then we have the certain application of Bernoulli's principle. Then if flux we see